In this worksheet, we're going to focus on linear growth. And what I'm going to have you do is create a function that represents each statement. Use function notation, f of x for each, and I'll explain that in a second. Explain what the independent variable is, x. So independent is going to be my x. Explain what that represents, and what the f of x, which is going to be our output, represents. So really quick with the notation, typically we see function notation like this. So here's a concrete example. I have f of x equals 3x plus 5, and if I asked you to find, if I asked you to find what is f of 2, that tells you to sub in 2, which would give me 6 plus 5, which is 11. So the independent variable is 2, and the dependent variable is what our output is. We could also see this when it's linear. Sometimes you'll see it not in function notation, which would be y equals 3x plus 5, where x is still the independent variable and y is the dependent variable. So our y would be our output here. So that's just two different ways that you can see it. I'm looking for this in function notation for each one of these, and I don't want to see the y equals. I want to see it as a function f of x. All right. So one more thing that I should talk about with linear equations, we need a initial amount. I'm going to call that an initial value, and then we need a rate of change. And if we think of this in terms of a function, the initial value is usually our y-intercept, and the rate of change is our slope. So I'll give you one more example before I actually get into these. I'll draw this axis over here, where this is my x and this is my y. And let's say that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say I start here, and then I go up 1 over 2. This would be a linear function. And with this one, I started at the y-intercept of 3, or my initial value was 3. So I would have this one as 3. That's going to be my initial value. I'm just going to write it in the back. And then I need to figure out what is my rate of change. And this time I went up 1 over 2. So remember, rate of change or slope is rise over run, and I'm going to give you another formula that is the same thing as rise over run, just written a different way. But this one went up 1 over 2, so my rate of change would be 1 over 2, and I always want to multiply that one by the dependent variable, so it's 1/2 x plus 3, which means every time my x increases, I'm going to multiply that by 1/2, and I'm going to add my initial value 3. So that would be this function over here. Probably a little bit confusing at the moment, and hopefully as I go through these, this will make a little bit more sense. But for each linear graph, I need an initial value, and then my dependent variable, which is going to be x, needs to be added to that or subtracted if it's negative, but added or subtracted to that where it's being multiplied by our dependent variable. So let's start with the first example. The bookstore has 2,000 books and is adding 15 more books each month. So how can I write this? I know I want it in the f of x notation, and I can start with the initial value. All right, so typically we see the initial at the end. So I'm going to write 2,000 at the end. That's how much if I had 0, right? If I'm in month 0, I started with 2,000 books, but then it's adding 15 more books each semester. So that's going to be 15 times x, where 15 is my rate of change. So I have f of x equals 15x plus 200. And if you just give me that, you have given me the function. So you've given me this part. But what you haven't done is you hadn't told me what the independent variable is and what the output represents. So x represents the month. So after month 1, I'm going to have 15 times 1, which would be 15 plus 2,000. I will have 2,015 books. After month 2, I would have 15 times 2, which would give me 30, plus 2,000, which would give me 2,030 books. After month 3, I would have 15 times 3, plus 2,000, which would give me 2,045 books. but X represents the months, so that is me telling you what my X represents. And then f of X is the output, and this is going to be the number of books in the library. So I want all of this as your answer. All right, I need the entire thing, and that's going to be this first linear equation where you're also explaining to me what your X stands for and what the function or the output f of X is representing. Let's look at the second one. A gym membership is $25 plus $5 each time you visit the gym. So the $5 each time you visit the gym, that's going to be my rate of change. So I know I'm going to have 5 times X, and then the $25 was just the initial membership cost. So if I add my initial value, I'm adding 25. So once again, that's going to be my function. And now I have to tell you what each one of these represents. X was $5 each time you visit the gym. So the 5 is the 5, and then X represents each time you visit the gym. So I'm going to call this gym visits. And you can word it how you want to, but that's gym visits. It's not $5 each time I visit the gym. The 5 was already taken care of out here. I'm just talking about the X, which is the number of gym visits. And then the output is your total cost, and that would be what I'm looking for. So $5 times every time I visit the gym plus my $25 membership fee will give me my total cost. So that would be how I would like to see the second example. Example 3, a certain type of bean plant grows at a rate of 5 inches every 2 weeks. So if you'll notice this is a rate, 5 inches every 2 weeks. That's a rate. I can use this as 5 over 2 X, but we need to be cautious here. If I do that, I have to keep in mind what my X is representing. I'll come to that in a second. But what I will notice in the first part of this, where my other ones had an initial value, this one doesn't have an initial value. So I'm always going to assume the initial value is 0. You don't always have to write plus 0, but if you're not given an initial value, we're going to assume that it's starting at 0. And like I said, you never have to write plus 0. You can just have 5/2 X. But let's write what this means. X represents the number of weeks. So this grew 5 inches every 2 weeks. We went ahead and did that 5 over 2. So now the X just represents the number of weeks. So it's going 5 over 2 inches every week, or another way of thinking that is 2.5 inches every week, which I may suggest that we could have just simplified this over here, 2.5 inches per week, where 2.5 is the same thing as 5 over 2. So it's growing 5 over 2 inches per week. And then f of X is representing the height of the plant. So in this one, if I had a plant for 4 weeks, I would just do 5 over 2 times 4, which would give me 20 over 2, which would be 10 inches. So that's what I want you to do for the first part of this assignment. I think y'all have 1 through 8 to do. And then for the second part, I'm going to do a couple examples, but for this, I want to find the rate of change given each scenario, and then I want you to put this into words. Now, some of them will make a lot of sense. Some of them, you'll have to dig a little bit into the words to figure out what the rate of change is and how to put that in words. Some of them will be worded pretty much the same as how I want you to put it in the words. But let's think about rate of change 1 second. So we've already used a couple different words for rate of change. We could see slope. Another word we could see is what's the average. Average could mean rate of change. Another thing we can think of is amount over time. What's the amount over time? That kind of leads back to what we're thinking of is when we think of the average. And let's come off of slope. We said slope was rise over run. Mathematically, rise over run is the y values, the change in the y values over the change in the x values. So these are going to be the two that I use a lot. and I'll show you how this one kind of ties in with this one. So mathematically, we've probably seen this before. The slope is y2 minus y1 over x2 minus x1. That's the change in the y value, which gives us our rise, divided by the change in the x value, which gives us our run. That's going to be what we're going to use here. Depending on the scenario, I can think of it this way, or I can think of it this way, but I'll show you, at least in one example, of how those two link together. So in this first example, the average adult breathes in 37 liters of air every 5 minutes. What is the rate of change in the volume of air per minute? So I'm looking for this per minute, and I'm going to use this one to start with, right? So this one would be 37 liters over 5 minutes. So I'm going to grab my calculator. I'm just going to turn this into a decimal. 37 divided by 5 gives me 7.4. If I put my units, this was liters per minute, it's still going to be liters per minute. So my rate of change is 7.4 liters per minute. That would be my rate of change. And for that one, I just use amount over time. I'm going to come back to this one in a second and show you how we're going to link that to y2 minus y1 over x2 minus x1. With the second one, the price of a loaf of bread increased from $1.45 in 2003 to $1.78 in 2006. What is the average price increase per year? So for this one, you can see that I have two values, right? I'm not starting with my initial value. I'm just starting with 1 point, and then I'm moving to another point. So I want you to think of these in terms of x's and y's, right? So the x value here is going to be my years. So it seems a little bit different than the way I read it, but that's my dependent variable, right? And my independent variable is how much it costs. Your independent variable needs to be your y value. So this is 2003. It was $1.45. And then same thing over here in 2006. It was $1.78. So I've thought of these as order pairs, and now I'm going to do y2 minus y1 over x2 minus x1, which gives me, and it doesn't matter which ones you call these, just make sure your x's and y's match up. If I call this one x2, y2, then this one up here has to be x1, y1. So this would be $1.78 minus $1.45 all over 2006 minus 2003. Grab my calculator. $1.78 minus $1.45 gives me 33 cents. And 2006 minus 2003 is going to give me 33 cents divided by 3 gives me 11 cents. All right, so 0.11. So this is 0.11, and if I think of it as dollars per year. So it's decreasing $0.11 or 11 cents per year would be my rate of change. That process probably seemed a little bit tougher than my first example. Recall that I had two different equations that I said we could use. This one is the one we just applied, and with example 1 I just did amount over time. But if we think about what this one was, if I want to think of it as two different points, my initial amount at 0 minutes, my person had breathed in 0 liters of air. So that would just be 0, 0. My second point would be at 5 minutes, the person has breathed in 37 liters of air. So if I thought of it this way, my y2 minus y1 over x2 minus x1 would simply be 37 minus 0 over 0 minus, over 5 minus 0. Let me backtrack. Over 5 minus 0, which leads me to 37 over 5. So if we're ever treating the initial value at 0, 0, or if there's not an initial point that's given to us, we're assuming that it's going to be 0, 0. When we subtract those zeros, that's leading us just simply to the unit of measure over the value of time. So it's essentially the same equation. We're just kind of skipping that minus 0 step that we would see here. Right. In the next example, a teenager's heart pumps on an average of 7,200 liters of blood every 24 hours. What is the rate of change in volume of blood per hour? So I could think of this as 0, 0 as my initial value, or I could just take the volume of blood and divide it by 24 hours. And now I just want to reduce that fraction or turn that into a decimal. 7,200 divided by 24 gives me 300 liters per hour. Okay, so I have done all the math, and I promise you the video is about the end, but I've done the math for the first three, and I don't know if I've actually put these into words, and that's what I wanted to hold off on later. So this first one, the average adult breathes in about 37 liters of air every 5 minutes. What is the rate of change in the volume of air per minute? And we found it to be 7.4 liters per minute. So we could say this: a person breathes 7.4 liters of air each minute, right? So I want this part too, and I've chose to just do the math first and come back and do these. You can obviously write the sentence that corresponds with it as you do the math, but that would be the first one. The second example, it says the price of a loaf of bread increased from $1.45 in 2003 to $1.78 in 2006. What is the average price increase per year? And we found that answer to be 11 cents. So we could say this: each year, the price of bread increases 0.11 which is the same thing as 11 cents. If you wanted to actually just write out 11 cents per year, you can do that. And for my last example, a teenager's heart pumps an average of 7,200 liters of blood every 24 hours. What is the rate of change in volume of blood per hour? And we found that to be 300 liters per hour. So we can say this: a teenager's heart pumps 3,000 liters per hour or each hour. So I'm not looking for yours to be worded exactly like mine, but I am looking for you to write this in a sentence. What we have mathematically over here, I want you to write it in a sentence over here. So I'm going to leave the rest for you to do. You have numbers 9 through 15.